Redox signaling science is basically a very new field. It's only been around for about 10 years. Scientists are gradually getting involved with redox signaling because they realize that it's such a fundamental process in human physiology. Plants and animals and lower forms of life and all forms of life used redox signaling messengers in order to repair themselves. Let me explain a little bit how that works. When a cell becomes damaged, there are certain messengers that are set out. It's called oxidative stress messengers. Those messengers then are able to tell the tissue that something is wrong. The tissue then is able to respond to that by a variety of different methods. It'll increase antioxidant production, for example, and efficacy. It will try to repair itself. If it's not able to repair itself, then the cell will actually end up killing itself and be replaced by other surrounding healthy cells. This is a remarkable process because it is actually the process which allows us to regenerate tissue and maintain our health. Damaged cells need to be detected. They need to be either repaired or replaced. And so this protection, detection, repair, and replace mechanism is absolutely fundamental to all life. So one of the interesting aspects of this discovery is that we've actually learned how to take these same redox signaling compounds that exist inside our cells and produce them in stable form outside our cells. A stable form that has shelf lives of months. And so then this signaling compound can have the kind of bioactivity that has been played out in our scientific investigations. And we actually see the fruition of such. We see, for example, that cells in cultures, in laboratories, are able to increase the antioxidant efficiencies, for example. Cells are able to elicit different responses that are involved in this repair, replace, and detect mechanism that allows us to regenerate tissue and heal ourselves, basically. And we're actually seeing real evidences, or at least anecdotal evidences, that these things are taking place. At that point, I realized that this is real. It's true. It's happening. And this technology needs to be distributed as far and wide and as quickly as possible. This became almost my cause, a cause for me. In a way, because this redox signaling molecules and system had so much potential, so much great potential to help people on this planet. And I almost felt as if I was given this technology and that this kind of was coming together almost on its own volition, if you will, because it was something that needed to be done at this particular point in time. This technology has the potential of spearheading some of the greatest advances of health in the world. And it's extremely potent. The idea or the possibility of being able to stabilize redox signaling molecules and use them as bioactive, non-toxic agents inside our body is phenomenal. And it will make a difference, and it will be the future technology that will affect almost all areas of health science and well-being.